Hey guys, welcome back to the series dedicated to Oxford Mathematics admission test. It's fresh 2019, October 30. So this question type B, it's about, basically number series. Okay, so let's consider. So we need to figure out the appropriate statement for, appropriate, choice for the statement. We have the product of square number. So square number multiplied by cubic number. Okay. So we just simply can test each statement, right? So for example, if we consider statement A about always square number and never cube numbers, just simply give several, examples, counterexamples that contradict to your statement. Yes? If you be able to find out one contradiction at least, so the statement is not true for the general case, right? So okay, let's test that it will be always a square and not to cube. Okay, we are not restricted to numbers for the square number and for the cube. So we can take even equal numbers, even different, even integers, or any real numbers, even complex if you like. Okay, in this case, just square number, it might be, let's say, 1 square, because 1 is a square number, so the result is 1. And cubic number, so we can take 1, let's say, cube, right? That will give us also 1. Or we can take, for example, another, but let's see, always a square number and never cube. So in this case, we got as the product, if we multiply them, we'll get both square number and cubic, because 1 is both square and cubic, okay? Or you can test with 1 as a square number, and instead of like 1 cube, you can take, let's say, cubic number, which is 2 cube, which is 8. So if you multiply them, the total result will be 8, and that's definitely cubic number. So statement A is definitely false, means always a square and never cube. No, it's not true, so we eliminate A. Okay, so always a cube number and never a square. Actually, what we tested before, there was both, right? A cube and a square when we took 1 squared and 1 cube. So we'll get the result is 1. So basically 1 is a square and a cube, so both. So B also is false, because this example just contradicts. Okay, so C, statement C, sometimes a square, sometimes cube number. So looks like this is the case, but sometimes means that sometimes it might be, other type of numbers, like not square and not cubic at all. So we'll stay at C and we come back later. So let's go to statement D, never square, never cube. That's false because actually our examples contradict, so we eliminate D. And always cube and always square. All right. So now if we be able to find out statement E is like always the truth, so E will be correct, otherwise C will be correct. So we have two questions, and let's test first E. So always cube and always a square. So we need to give an example to have a contradiction with just simply having not cube and not square number. Okay, so square number, which number we can take? For example, let's say, let's say we get 1 and cubic letter B. So we need to have something like 4 as 2 squared. And for example, next one, let's take 8. So 2 cube, which is 8. So 2 cube. We multiply them. So we'll get 2 to the power of 5, which is 32. So the result is 32. And so it looks like 32, no square and non-cubic number. It's just other integer. So statement C in this case is correct. So we have the question sign and we eliminate E. So C is correct. As you can see, just simple, try to find contradictions to your statement, and that how you can test it. So in general approach, like universally, like, trying to write square number as in general form and cubic number in general form is quite, it's quite hard. So you'll save your time if you just simply pick up some contradictions. Alright, so if you like my explanation, just subscribe my channel and just we'll be keep on track. So I'll try to pick up other types soon and you'll have a right and detailed explanation. Okay, so I hope you enjoy it and see you later.